Hello guys, in this video we are going to discuss the solution of the problem max sum path in two arrays. So let us look at the problem statement. The problem statement says given two sorted array of distinct integers array 1 and array 2, each array may have some elements in common with the other array. Find the maximum sum of a path from the beginning of any array to the end of any array. You can switch from one array to another array only at the common elements. So for instance, if these are the two arrays which are given to us, the maximum sum which is possible over here is 35. And the way we will be able to get to this sum is by adding the elements 1, 5, 7, 10 and 12. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take two arrays. So let us say these are the two arrays which are given to us. And then there are some common elements between these two arrays. So let's say C1 is a common element. Similarly, C2 and C3 are common elements. Now at these common elements, we are allowed to move to next array. So the general idea behind solving this problem is compute sum1 and sum2, where sum1 is equals to sum of all elements from array 1, and we are going to compute this sum before a common element. Similarly, sum2 is the sum of all elements from array 2, and please note all these elements are before the common element. So let me explain it in a bit. So let us say this is my sum1. So this portion is what I'm going to store in sum1. Similarly, sum2 is this portion. So this portion will be stored in sum2. Now after sum1 and sum2, we see that we have encountered a common element where C1 is the common element. So once we encounter a common element, we will choose which sum is to be taken. So what do I mean by this is, we have reached a common element C1. Now we have an option of choosing either sum S1 or sum S2. And that is exactly what we are going to do. So in this case, since our objective is to maximize the sum, and let us say result contains the maximum sum, so then result will be equals to result so far plus maximum of sum1 or sum2. The one which is maximum is what we are going to take. And please note, this is something which we are doing when we have encountered a common element. And after adding this, let us add the common element as well. So the common element, let us say C1 is the common element. So C1 we will add it. And again, the same thing is what we are going to do. So what do I mean by this is, let us now write down the sums over here. So let us say this is S1, this is S3, this is S4, and this is S5. And these are essentially, so S3 is the sum of these three elements. Similarly, S4 is the sum of these three elements, which simply is the elements between the two common elements. Similarly, S5 is the sum of these elements. And in the same way, we are going to compute these sums as well. So let's say this is my S6, which is the sum of these elements, S7 and S8. Now at each common element, we have a decision to make. So our result in this case will be result so far plus, let us say we have reached the common element C1. So now we have to choose between S1 and S2 what is the maximum. So this will be equals to max of S1 and S2 plus, let's not forget about the common element, so C1 plus, again we have reached a common element which is C2, and the maximum sum between S3 and S6 is what we have to choose. So this will be equals to max of S3 and S6 plus the common element C2. Similarly, when we encounter a common element C3, then we have to make a choice between S4 and S7. So let's do that. So this will be equals to between S4 and S7 and the common element C3 plus, now we are left with the sum S5 and S8. And again the same thing, the maximum between S5 and S8 is what we are going to add. So this will be equals to S5 and S8. And this is what will give our answer, or rather the maximum sum. Now let us take an example to illustrate this idea. So let us say this is the array which is given to us, and as we can see, there exists just one common element, which is 7 between these two arrays. Now with this common element, let's have our S1 and S2. Similarly, let us say this is my S3 and this is my S4. So in short, S1 is equals to 2 plus 3, which is equals to 5. S2 is equals to 10 plus 12, which is equals to 22. S3 is equals to 1 plus 5, which is equals to 6, and S4 is equals to 8. So our answer will be equals to max between S1 and S3. So the maximum between S1 and S3 plus max between S2 and S4 plus the common element, and the common element is 7. So in this case, the between S1 and S3 the max is 6, and between S2 and S4 the max is 22 plus the common element, and the sum which we obtain is 35, and this is what we are going to return. So that's the example, folks. Now let us discuss how we will be able to compute these intermediate sum efficiently, and at the same time we will be able to compute the result value. So now let us discuss how we will be able to do this efficiently. So to do this efficiently, what we are going to do is we are going to take an I pointer and we are going to set it at the beginning of array 1. Similarly, we are going to take a j pointer and we are going to set it to the beginning of AR2. And our objective is to find the common element. And while finding the common element, we are also going to compute the intermediate sum. So let us discuss how we will be able to find the common element. Now in order to find the common element, what we are going to do is we are going to iterate on I and j while I is less than ARR1 length and j is less than ARR2 length. Simply, we are going to iterate on all the elements of both the arrays. And we are going to check whether ARR1 I equals to ARR2 j. If they are equal, then we are going to perform some operation, and this is the case where we have found our common element. The second case is these elements are not common, in which case elif ARR1 I is less than ARR2 j. If that is the case, then again we are going to do some operation over here. Otherwise, the final case where ARR1 is greater than ARRJ, which is our case. So as we can see, 2 is greater than 1. And since our objective is to find the common element, so what we are going to do is the one which is lower, so in this case j is lower, we are going to compute the sum of a smaller array and we are going to increase our j. Since by increasing j, the value will increase, and in that way we will be able to find the common element. So let me explain it a bit more. So what do I mean over here is, if let's say ARR 2j is smaller, so let's say this is smaller, then S2 will be equals to S2 plus ARR 2j, and j will be increased by 1. So as you can see over here, what I am doing is I am computing the sum S2. And now let us update our S2 and j pointer. So now j moves to the next position, so j reaches over here, and our S2 is equals to 1. Similarly, our S1 equals to 0. Now the next case is where I is at this position and j is at this position. So since 2 is less than 5, so we are going to compute S1, and S1 will be updated by 2 and I will be increased to the next pointer. So I will come over here. And similarly, let us write the code for this block. So if ith element is less than jth element, then in such case S1 will be equals to S1 plus ARR1I, and I will be increased by 1. Now let us apply these two logic in order to compute this S1 and S2. So in this case 3 is less than 5, so S1 will be equals to 2 plus 3, which is equals to 5, and ith pointer will be increased, so I will come over here. Now 7 is greater than 5, which simply means S2 will become 1 plus 5, so S2 will be 6 and j will come to this position. Now at this position, the ith and jth element are equal. Now we have reached the case where we have obtained our common element. Now since we have obtained our common element and we will be in this block, in that case we have a decision to make, which is what will be the value of result. And the value of result will be given by the value of result so far plus the maximum between S1 and S2 plus the common element. And once we do this, what we are going to do is we are going to set S1 and S2 to 0, and I will be increased by 1 and j also will be increased by 1. So let us do that. So with this, our result will be equals to the max between S1 and S2. So the max between S1 and S2 is 6 plus the common element, which is 7. So the result is 13 so far, and S1 and S2 has been initialized to 0. So S1 is 0 and S2 is also 0. Again, we will compute S1 and S2. So this S1 will be essentially 10 plus 12 and S2 will be equals to 8. And between this 10 plus 12 and 8, since 22 is greater, because of which the result will be 13 plus 22, which is equals to 35. And in this way, we will be able to find the common element efficiently, and at the same time, we will be able to compute S1 and S2. And using S1 and S2, we will be able to compute our result value. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find max path sum, and array 1 and 2 is given to us. Now the first thing which we are going to do is we are going to take S1 and S2, and the initial value is 0. Similarly, I and j, initial value is 0 and result is also equals to 0. Then we are going to iterate on I and j while I is less than len of ARR1 and j is less than len of ARR2. And let's have our three cases. If ARR1 ith element is equals to jth element. If that is the case, then let us update our result. So result equals to result plus max of S1, S2 plus the common element. And once we do that, let us update our I, j and sum1 and sum2. So I will be increased by 1. Similarly, j and S1 and S2 will be set to 0. If this is not the case, and let's say the ith element is less than the jth element, in which case we will be able to compute our S1, and S1 will be equals to S1 plus ARR1I, and I will be increased by 1. Similarly, if this is not satisfied, then that simply means jth element is smaller, in which case we are going to compute the sum S2, which will be equals to S2 plus ARR2J, and then J will be increased by 1. Now, and in this way, we will be able to compute S1 and S2, and in this way, we will be able to compute our result. Now, it might be possible that the loop breaks, but there exists some element in ARR1 or ARR2. So for such case, while I is less than len of ARR1, all we have to do is we have to compute our S1, which will be given by S1 equals to S1 plus ARR1 I, and let's increase our I by 1. Similarly, if there exists any element in ARR2, then that will be covered using this loop. And in this case, we are computing S2 sum. And then towards the end, all we have to do is we need to return result plus max of S1 comma S2. And in this way, we will be able to compute the maximum sum path in two arrays. So that's the discussion of solution, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So we have sum1, sum2 array. Initial value is 0. Similarly, I, j and result, and the initial value is 0. Then we are iterating on all elements of array 1 and array 2. If the elements are equal, then we are updating our result and we are increasing our I and j pointer, and we are setting our sum1 and sum2 to 0. Similarly, if ith element is less than jth element, then sum1 will be updated and I will be increased by 1. And if jth element is smaller, then sum2 will be updated and j will be increased by 1. And then towards the end, if there exists any element in ith array or jth array, then either S1 will be updated or sum2 will be updated, and towards the end, result will be equals to result plus maximum of sum1 and sum2. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So folks, the C++ solution is also the same. We have I, j, sum1, sum2 and result. And then we are iterating on array1 and array2. If they are equal, then the result will be updated. Otherwise, sum1 and sum2 will be updated. And then towards the end, all we are doing is result plus maximum of sum1 plus sum2. And then towards the end, all we are doing is result plus max of sum1 comma sum2. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.